we have, the RUDAC is yet, just the volume of the RUDAC we have to check to make sure the chip gonna function, manufacturing correctly and then function at the end. It's just so much different than, like 10 or 15 years ago. So, and another thing that makes it always challenging is if we're gonna come through and we design a chip that go through so easily, that means we haven't pushed it far enough, right? So, and they say, wow, that's mean we have not optimized it enough, right? We need to make it better. So that's the desire to always make it lower power, higher performance in a smaller area, right? That's continue strive for a better product. So that make our job actually harder, right? Because if we make it too easy, then we only come back and say, let's try a little bit harder. So um, and here it just, the point here is that this step is dependent heavily on the quality of the previous step, right? If we did a good job in previous step, then hopefully we get an easier time during this. If we mess up, then definitely we're not going to be able to go through this step. It's very much more likely we're going to fail. So, and one of the reasons for that is because when we get to this point, right? So very much everything has been fixed, right? Everything that we think we should change, we committed, right? The how the chip gonna look like, where the macro gonna be placed. So all those we already make the decision on those, right? So this is just like put everything together, right? Just connect everything together, right? So we don't have a lot of choices. The last step is just, yeah, let's connect everything together, right? So okay, so let's see. So I'm gonna have uh, some picture here, kind of like repeating what we mentioned on previous slide, so it's easier to kind of like picture. So what we see here is if you look at the technology, right? Back in like 130, we have like generally we have like 6 layer, and you look at it, they all the same, right? And then you move to 90, we introduce thicker layers, right? And then 65, essentially additional thicker layers. So the complexity getting, we get more layers, and the layers are vary, right? They're not the same anymore. So, and whenever you have that, the tool gonna treat them differently, right? So the complexity you just, multiply. Um, so we're gonna talk about on the middle picture here. Let me turn on the clear option. We're going to talk about the G cell later, but essentially just compare on a thin, within the same die or chip that we're working on, depend on which layer, um, the number of track and routing resource within the same G cell, very different, right? We just, on the top layer, we can only fit like just a few, but on the lower layer, we can fit like 10, 15, right? So, and then the same thing very much for via here. So the thickness of the metal chain the VR chain, right? And that lead to what? The spacing of DLC gonna change, right? The complexity multiply again, right? So, and you can see here the same story here, right? So on a older technology, the spacing very much uniform, right? It's just certain X number. But as the technology keep advancing, the spacing rule is very complex, right? So it's not going to be like just a single rule. It's going to have like fat mirror